This video is about optimization problem, and so here I have a circle with fixed radius r, a sector with central angle theta is cut out, so this sector right here, and then this remaining piece, from this remaining piece, a cone is formed. And so notice that the slant height of the cone is also the radius of the circle. And so as theta changes, we get a different cone. And so we get a different volume. So we want to find the cone with the largest volume and then find the corresponding theta. So once again, as theta changes, the volume of the cone also changes. And so we want to find the cone with the largest volume and then find the value of theta corresponding to the cone with the largest volume. So here's the original circle with radius r, and so the circumference is 2 pi r. For the sector, the cutout sector, the area of the sector is 1/2 r squared times theta, and then the length of the sector is r times theta. And then here's the cone that's formed. So so let h be the height of the cone, and then let r, the small r, be the radius of the base of the cone. And so notice that the circumference of the base of the cone is 2 pi r, but it's also 2 pi times big R minus big R times theta. This is the circumference of the original circle, and then this is the length of the sector, the cutout sector. And then we also have r squared plus h squared is equal to r squared. The volume of the cone is 1/3 times pi times r squared times h, but r squared is big R squared minus h squared. And then simplify, we get 1/3 pi r squared h minus 1/3 pi times h to the third. And we want to maximize the volume, and so let's take the derivative from here with respect to h. So the derivative of this term be just 1/3 pi r squared, and then for here, for this term, we get 1/3 pi times 3h squared, the derivative, which is pi h squared. Set the derivative equal to 0. So we get this 1/3 pi r squared minus pi h squared equals 0. Divide everything by pi, then we get 1/3 r squared minus h squared equal to 0. So h squared is 1/3 times the radius of the circle squared. Or h is the radius of the circle dividing by the square root of 3. And then once again, we have r squared plus h squared is equal to big R squared. But h squared is 1/3 r squared. And now subtract 1/3 r squared from both sides. Then we get small r squared is equal to 2/3 times the big R squared. Or the radius of the base of the cone is the square root of 2/3 times the radius of the circle. And so what it means is that to get or to attain the cone with the largest volume, h, the height of the cone, must be the radius of the circle dividing by the square root of 3. And then the radius of the base of the cone must be the square root of 2/3 times the radius of the original circle. And so the cone with the largest volume will have a volume of r squared is 2/3 times the radius of the circle squared, and then the height needs to be the radius of the circle dividing by the square root of 3. And then simplify, we get 2 pi dividing by 9 times the square root of 3, and then times the radius of the circle to the third. And so this is the volume, the volume of the cone with the largest volume. And now let's find theta, which is the central angle of the cutout piece. The length of the sector here is r theta, and then notice that the distance of this piece right here, the distance from here to here, this is the same as the base of the cone. It's the same as the circumference of the base of the cone. The circumference of the base of the cone is 2 pi times the small r, and so this piece right here would be 2 pi times big R minus r theta. So it's just the circumference of the original circle minus the length of the sector. And then from here, move this term to the right, and move this term to the left, and move this term to the right. And then we get theta is equal to 2 pi times the radius of the circle minus 2 pi times the radius of the base of the cone, and dividing by the radius of the circle. But earlier we got the small r is equal to the square root of 2/3 times the big R. And then divide everything on the top by big R, divide everything on the bottom by big R. And we end up with 2 pi minus 2 pi times the square root of 2/3, which is approximately 1.152 radians. And so to attain or to get the cone with the largest volume, and then theta must be about 1.152 radians. And that's the end of the video.